right? Paper 4, electronics. Shortcut. Okay. We discussed yesterday class about the logic gates, na? Right. In that, we started, I think, flip-flops. Huh? No. Applications of XOR gate. We discussed off adder, full adder, and off subtractor, full subtractor also. Okay. After that, next one, De Morgan theorems, fundamental products, and K maps. Na? In the De Morgan theorems and De Morgan theorem, fundamental products also. Okay. Sum of product, product of sum. Okay. After that, K map. Okay, na? K maps. 2 variable K map, 3 variable K map, 4 variable K maps. Okay. In that, the K map, Korangap map. The K map is easy and straightforward method. The K map is easy and straightforward method. Easy and straightforward method to simplify the Boolean functions. To simplify the Boolean function. SIMP LIFI, simplify the Boolean function. Okay. This method may be regarded as a pictorial form of truth table. Pictorial means pick methods. Note on yourself. This method may be regarded as a pictorial form of a truth table. Okay. In that, for example, 2 variable K map, 3 variable K map, 4 variable K map. If 2 variables, then combinations 4. Already we know. 3 variable combinations are 8. That will be 8 cells, we can take it. Combination, see the number of cells on. 2 variable K maps, I'm taking here with 4 cells. One input A, other input B. Okay. M0, M1, M2, M3. Maybe A value is 0, 1, or B value is 0 or 1. Similarly, 3 variable K maps. Means 3 variables, you will get 8 cells. Input A and BC here. Yeah. It is a purely based on a gray code number. Gray code number means one bit only it can changes one cell to another cell. In that order only they can arrange here. So in that way, A value 0 or 1. BC value maybe 0 0 or 0 1 or else 1 0. Won't get here 1 0. అంటే 0 1 నుంచి 1 0 కి స్టార్ట్ చేస్తే ఏమవుతుంది, ఫస్ట్ బిట్ 0 నుంచి 1 చేంజ్ అయింది, సెకండ్ బిట్ కూడా 1 to 0 చేంజ్ అయింది, 2 బిట్స్ చేంజ్ కావడం. ఫర్ ఎగ్జాంపుల్ ఇక్కడ చూడండి, 0 0 నుంచి 0 1 కి ఫస్ట్ బిట్ 0 యాజ్ టీజ్ గా ఉంది, సెకండ్ బిట్ 0 నుంచి 1 చేంజ్ అయింది. ఆ బేస్ మీద ఉంటుంది. అంటే 0 1 నుండి 0 1 నుంచి గోస్ టు 1 1. అంటే సెకండ్ బిట్ 1 ఎలాగుందో యాజ్ టీజ్ అలాగే ఉంది. ఓన్లీ 0 ఫస్ట్ బిట్ 0 నుంచి 1 చేంజ్ అయ్యింది. సో 0 0 0 1 తర్వాత నెక్స్ట్ డిజిట్ వచ్చేసి 1 1. దెన్ నెక్స్ట్ హియర్ 1 1
సార్
2
ఇది ఏ యూనిట్ సార్?
goes to 1 0. This is the third unit.
థర్డ్ యూనిట్. పేజ్
Block
నెంబర్
3 unit page number 218.
208. ఓకే, థ్యాంక్ యూ.
Block 3 third block unit number 16.
16.
De Morgan theorems, fundamental products and KMFs.
209.
Yesterday ఎక్కడైతే ఆపానో అక్కడ నుంచి కంటిన్యూ చేస్తారు.
ఓకే సార్, కంటిన్యూ.
Right? Here 3 variable KMFs. ఈ ఆర్డర్ తెలియాలి. Here M0, M1, M2, M3, M4, M5, M6, M7. Okay, that value is taken this order only. If you want to take here 0 0 0 0 1, here 0 1 1, 0 1 0, like that. In this order numbers. If you want to put 0 0 0 0 0 1 0 1 1 0 1 0, we'll get 1 0 0 1 0 1 1 1 1 1 1 0. Okay, these are 3 variable. Similarly 4 variable also. అప్పుడు ఇక్కడ ఇంకో పెడుతుంది, ఇక్కడ ఏబి బిసి. ఓకేనా, రైట్. KMFs 2 వేరియబుల్, KMFs 3 వేరియబుల్స్ అడగవచ్చు. రైట్, 3 వేరియబుల్స్ అవుట్పుట్ కావాలంట. వన్ సి పేజ్ నెంబర్ 220. 3 కాంబినేషన్స్, 3 వేరియబుల్స్ ఇచ్చిన కంటే 8 కాంబినేషన్స్ వస్తాయి. 3 zeros 3 ones. సారీ, 1 second. Once go through it, page number 220, truth table. 3 variable KMF truth table. Inputs A, B, C. So for that one, possible input combinations 0 1 0 1 0 1 0 1. Here we'll get Y. Okay, output. So in that min terms or maxima terms, you can cross check. Min terms or maxima terms, you can note down here below. Note. Min term purpose, you can apply OR gate. Min terms for you can apply for input combinations OR gate. And maxima terms apply AND gate. OR gate, AND gate. Okay. That to be this to be will get M0 value, M1, M2, M3, and so on up to M7 work will get. M4, M5, there you go, M6, M7, like that values. After applying that logic, we'll get here 0, 1, 0, 1, 0, 1, 1, 0, 1, 0. There is nothing but XOR gate output type only. Okay, na? In that one again, space, quotes, and furtherly will get. That part you can see from your book, page number 221. Okay, right. In this one, just you can go through it, short answer questions, only 2 questions. Write the postulates of Boolean algebra, page number 223. Write the postulates of Boolean algebra. Second one, explain the duality theorem. This is already repeated in the previous one only. State and prove De Morgan laws. In these 3, enough examination point of. Okay, right. The next you can go
థర్డ్
to
క్వశ్చన్ మళ్ళీ ఒకసారి రిపీట్
seven,
చేయండి సార్.
first 3 questions.
ఫస్ట్
Textbook lo ఉన్న
ఓకే
first three questions.
ఓకే సార్.
Next one, important one, flip flops. It can useful in practical point of view, even the theory also same knowledge. Here onwards, flip flops, registers, counters, these 3 topics it can use dual side, practical and theory. So write in one sentence about the flip flops. I dictate here, hardly one or 2 lines. Note down everyone. Flip flop is a circuit. Dictate yes, Rasu 2 lines. Flip flops. Note down. Flip flop is a circuit that has 2 stable states. TW2. Flip flops is a circuit that has 2 stable states and can be used to store state information. Can be used to store state information. Please stop. A flip-flop is a bistable multi-vibrator. A flip-flop is a bistable multi-vibrator. The circuit can be made to change state by signals applied to one or more control inputs and will have one or more outputs. It is a basic storage element in sequential logic. Last point. Flip-flops and latches are fundamental building blocks of digital system. Fundamental blocks of digital system. That's it. సో సింపుల్ ఒక వర్డ్ లో చెప్పాలంటే ఫ్లిప్ ఫ్లాప్స్ డేటా స్టోరేజ్ చేయడానికి యూజ్ చేస్తాం. ఇట్ ఈజ్ ఏ ఫండమెంటల్ building blocks in digital system. Okay, that's it. And one important SAQ here. Sometimes they'll ask types of flip-flops. Just simple types of flip-flops. Just names only enough. In that one, first one, RS flip-flop. RS flip-flop. R indicates reset, S indicates set. R indicate reset, no need to write, just to remember. S indicates set. Set reset, like reset set type. RS flip-flop. Next to second one, clocked RS flip-flop. Clocked RS flip-flop. అంటే ప్రీవియస్ స్టేజ్ లో ఉన్న డేటా అలాగే ఉంటుంది, ఎప్పటివరకు ఇంకొక పల్స్ ఇన్పుట్ పల్స్ ఇచ్చేంత వరకు చేంజ్ అవ్వదు, అది అలాగే ఉంటుంది. క్లాకింగ్ ట్రిగరింగ్ క్లాక్డ్ RS flip-flop. నెక్స్ట్ థర్డ్ వన్ D flip-flop. D flip-flop. Fourth one, JK flip-flop. JK flip-flop. Just names only enough. Next, JK master slave flip-flop. JK master or slave flip-flop. That's it. 5 names are 5 marks there. Lucky ga adugute. Again, now we have to discuss one by one. Sometimes they will ask only types of flip-flop. Okay, na? Okay, page number 225. 17th unit. Right. First thing in that one, most repeated important topics are in that one, RS flip-flop or else JK flip-flop. Okay, right. Again, RS flip-flop with NAND gate, RF flip-flop with NOR gate. Here condition. Maybe they can ask RF flip-flop with NAND gate. Maybe they can ask RS flip-flop explained with or NOR gates. ఒకవేళ ఏ గేట్ నేమ్ మెన్షన్ చేయకపోతే దట్ ఈస్ యువర్ విష్. గేట్ నేమ్ పర్టికులర్ గా మెన్షన్ చేస్తే ఆ గేట్స్ వాడే ఫ్లిప్ ఫ్లాప్స్ ని ఎక్స్ప్లెయిన్ చేయాలి. ఒకవేళ గేట్ నేమ్ ఏమడకుండా జస్ట్ ఎక్స్ప్లెయిన్ RF ఫ్లిప్ ఫ్లాప్ అంటే ఐదర్ నార్ గేట్ ఆర్ నాండ్ గేట్, దట్ ఈస్ యువర్ విష్. ఓకే, రైట్, బట్ ఇట్స్ ఇంపార్టెంట్ థింగ్ ఓన్లీ. RS flip flops. First I'm going to explaining first one, RS flip flop.
Literally.
Means reset set. RS flip flop with NAND gate. Already we know NAND gate in the story. Sorry. Okay. RS flip flop. What we can say, that is reset set. RS flip flop. RS flip flop with NAND and NOR. First we'll take NAND and NOR. Anything ఒకటి నేను చేస్తాను, ఒకటి మీరు. దట్స్ బెటర్ కదా. ఫస్ట్ ఐమ్ టేకింగ్ విత్ NAND ఓన్లీ. RS flip flops with NAND gate. లేదంటే NOR gate కూడా అడగొచ్చు. Or else they'll ask both. Right. In that one, RS flip-flops. RS flip-flops, it have two input and two output terminals with two NAND gates. For example, I'm taking here one NAND gate, other NAND gate. NAND gate, two inputs. Right. NAND gate output. One output name I'm taking here is a Q. Other one is a Q bar or Q dash. Right. This gate input, one is a set, other one is a reset. S indicates set, R indicates reset. And next one, other conditions. Here, one input, basically this output connected to input, this output connected to other side input. So this meaning is overlapping. Okay, no? Set, reset. For example, here input combination maybe 0 0, maybe 0 1, maybe 1 0, maybe 1 1. Total 4 combinations it can possible. Total 4 combination it can possible. In that, for example, if we know NAND gate or two tables 0 0 0 1 1 0 1 1. These are the if in case of inputs. Then output 0 into 0, 0 0 complement 1. Then we'll get 1 1 here 0 only. Na? This is A B. This is a output. For this is a rough work for NAND gate. This is the NAND gate truth table now. Instead of EB, you can give S and R input combinations. S and R input combination. Okay. When here giving one thing is 0, other one also 0. In the condition A value 0, B value 0, output is 1. If A value fixed, B value either 1 or 0. Means here S value is 0, then B value either 0 or 1 condition. In that condition, you will get output value is 1 only. So for that purpose, I'm taking for this RS flip-flop truth table. R value, S value, and Q. This output value I'm taking here. Input combinations 0 0, 0 1, 1 0, 1 1. When the both inputs are giving 0 0, R value, S value, then both the inputs are 0 0. In that condition, Q value means second NAND gate output value will be get prohibited. It won't get prohibited. Means it can like a blinking type. Prohibited value. When the values R value 0, S value 1, that is condition is will get a reset condition like 0. When R value 1, S value 0, then will be get a 1, that is called as set. When both the values are 1 1, no changes in the output value, that is called as a previous one, nothing but no changes, that is nothing but last value only. No changes, nothing but last value. Similarly, with NOR gates also you can check it. Okay, along with the two. So for that purpose, examination point of view, you have to explain one entries. First entry, both the values 0, 0 condition, S value 0, R value 0, then Q value 1, Q bar dash value also will get 1. Next one condition, S value 0, R value 1, the flip-flop Q value 1. Next, S value 1, R value 0, the flip-flop will be get set. Sorry, S value 1, R value 0, reset. So basically you can remember this table and you can explain one step wise on. Like entry 1, entry 2, entry 3, entry 4 type of.
Sir,
These are the, yes, tell me.
sir.
Sorry, repeat again.
Sir,
Tell me. వినపడుతుంది చెప్పండి.
you wrote before one table there, sir. NAND gate.
Yeah, that is a NAND gate table.
NAND gate means now you are explaining about NAND gate RS code. Both are different.
Both are different. That is a NAND gate. Sorry, this is a NAND gate truth table. This is a RS flip flop truth table.
Okay,
With NAND gate. RS flip flop. That is a, this is a rough understanding purpose only.
Okay, sir. Thank you.
Okay. Similarly, next RS flip flop with NOR gate. Then here gate value, gate will be changes. Instead of NAND, we'll get NOR. In that condition, we'll get quietly reverse order. When 0, 0 condition, no changes. Then next set condition first, reset condition next, then prohibited condition will get. NOR gate order will get input same combination, output value will get reverse order. NAND gate in this way, NOR gate ulta. Or as first only you can consider NOR gate, then you will get first one no changes, then set to reset to prohibited. Then NAND gate will get conditions reverse of NOR. Okay. Yeah. This is set to reset conditions. You can remember it. Next one, clocked RS flip flop. Clocked RS flip flop means in the every intermediate stage we have to give input clock. Every intermediate stage we have to give input clock, then output value it can changes. In that condition we can observe the output values. That is called as the clocked RS flip flop. That one is there in your material, page number 227. In that, clock pulsative 0 na 1 na. 0 indicates low volt, I indicates nothing but 5 volt, 1 indicates. In that one triggering transmission going from 0 to 1 na, 1 to 0 na. If the transition going from 0 to 1, that is a 0 to 1 increases, that is a positive going transmission. 1 to 0 decreases, that is called as a negative going transition. Okay, now once we can see in that one truth table also in your material, page number 228. When clock is low, both the AND gates are disabled. When the clock is low means 0 volt. When the clock is low, both the AND gates are disabled. And AND gate outputs are low. Any change in RS input will have no effect on flip-flop output Q.
ఇక మీద ట్యూబ్ ఇస్తుంది చాలు చేయి మరి లైట్ చాలు చేయి లైట్ చాలు ఎట్లున్నది ఫోన్ ఇది ఇప్పేసి లోపలికి సెట్ చేద్దాం.
Dear sirs and madam, please understand my problem. Don't speak middle of the class. Someone is making noise. better you can keep in silent mode. It will be better. If any doubt, you can chat in the chat box. I'll see that chat box also. I'll give the replay. Okay. Right. Thank you. Right. You can go through it, your material, page number 228. Clocked RS flip-flop with AND gate. That is there.
ఇక 10 లైన్ వద్దుతలేవు
Better I'll keep it mute. It's fine. Then no issue. ఇప్పుడు మీరు ఏం మాట్లాడినా నాకు వినపడదండి, సారీ. మీరు ఏదైనా చెప్పాలనుకున్నా జస్ట్ యూ కెన్ గో త్రూ ఇట్ ఇన్ ద చాట్ బాక్స్ విత్ మెసేజ్ ఓన్లీ. Someone already written the text. Use dark sketch pen. Okay. Ramesh, D. Ramesh. Oh, it's okay, sir. And next, like that, if any issue, sir, you can go through it. A message was only no audio message. Why? Because I kept all of in mute mode only. That's fine. One second. Let it be mute for all. So yes. Right. ఈ ఒక్క దగ్గర సైక్లిక్ లాజిక్ మిస్ అయితే ఫర్దర్ గా రాదు. దట్స్ ద ప్రాబ్లం. ఓకే. Where we are here. Clocked RS flip-flop. Clocked RS flip-flop. I can take in that one only. Clocked RS flip-flop. Flip-flop, and it will be easy to say the data storing purpose. S input, R input, the next other one is a output, one is a Q, other one is a Q bar. These are the outputs. Here these inputs are connected through AND gates. One AND gate, other AND gate. AND gate output connected to flip-flop inputs S and R. S indicates set, R indicates reset. These two inputs, one common terminal is giving a clock. CLK. Right? One input is a here set, other input is a reset. R, yes, set and reset. Okay. Now, when the clock is low, means the pulsative is a low. When the clock is, this clock is low. When the clock is low, both the AND gates are disabled. The AND gate output are low. In this condition, both the AND gates output value also will get low. That value RS flip-flop input means input RS flip-flop input also low. Any change in RS inputs will have no effect on the flip-flop output Q and Q bar. It means when S is equal to 0, R is equal to 0 condition. Like when the clock is 0, output of both the AND gates value also will get low only. In that condition, when you are giving low input of RS flip-flop, the output of Q also will get 0 only. He's saying like that. No effect of flip-flop, output Q, since R is equal to 0, S is equal to 0, the output of the latch. When the clock is high, remember first point, when the clock is low, output of AND gates value low, that output connected to input of flip-flops that is low, then we'll get output also 0, Q value 0. Second point, when here, when clock is high, the previous condition low, next one clock is high. When clock is high, this AND gates, when the clock is low, AND gates are disabled. When the clock is high, AND gates are enabled. Enabled means here output value of both the AND gates value also high. That value connected to input of RS flip-flop. Okay. RS flip-flop. In that condition, we have to observe the truth table of clocked RS flip-flop. Here two conditions. One condition, when clock is low, then two AND gates output value will get disabled, output value will get low. That is connected to RS flip-flop inputs. In that condition, you will get Q value 0. First point. The second point, when clock pulse is high, this is nothing but low indicates like this, which is indicates of low. I indicates pulsator like this. Indication symbol. Low I means here 1 to 0, here 0 to 1. Here positive going triggering, here negative going triggering. Or positive going triggering pulse, negative going triggering pulse. When the clock is high, the AND gates, both AND gates are enabled. Both AND gates are enabled means the output of RS flip-flop contains latch changes. The previous condition is 0, na? It can changes to 1. Q value it can changes to 1. Here Q value changes to 0 to 1. When input clock pulse giving positive or else high or else positive going triggering condition. Continuously it can changes. Set, then next reset, then 0, then next 1, like this continuously pulsate it can changes. In that one thing we'll observe along with the input combinations. I'm writing here. First one input is a R, other input is a S. So here combination. First one is a previous data. Previous data nothing but X something. Maybe 0 or maybe 1. That is the previous data. So in that condition, output of Q value, no changes in the previous something is there. That's something data only. It can reflect on the Q means output. This X nothing but the previous data one. Before we are using what data is storage in the flip-flop, that data only it can reflect on the flip-flops. After that, now we are giving low clock triggering means 0. Low means indicates 0 0. Then next 0 1. Then next 1 0 1 1. It can appear in a bottom, right? XX means that is the previous data. 0 0 0 1 1 0 1 1. When it is giving 0 0, nothing but we are clearing the latch. The data will be previous condition is clearing. Then no changes in the previous data in the output. After that, when you are giving high pulse to here, this is a low pulse. Then next we are giving high pulse, high clock pulse. When you are giving high clock pulse, it goes to 0 to 1. Then will we get here is a 1, nothing but set. Always 1 indicates set to 0 indicate reset. Set reset conditions. Again continuously we are giving positive triggering or else positive clock pulse, nothing but high clock pulse. So it goes to then next reset previous data. Then next it can goes to when you are giving both the inputs 1 1, it won't get. That is nothing but a prohibited. This toggling type only. When you are giving 1 1, that will be get a toggling type. In another way, this one clock pulse indication, this is a negative clock triggering. These are positive arrows. You can express in this way also. It means these last three entries are positive going triggering. First one negative going triggering on. Like this, we have to explain one entry in the stepwise. Okay. In synchronous condition only we are using clocks. In asynchronous, we won't use clocks. That thing you can remember. Synchronous, asynchronous. Asynchronous means two-way communication. Synchronous, one-way communication, simplest way. Like best example, synchronous walkie-talkie, asynchronous mobile phone. Both the sides we can speak togetherly at a time. Asynchronous. Synchronous is the best example is walkie-talkie. Okay, na? This is a RS clocked flip-flop truth table. These theory things you can explain yourself own words. Okay, done. Similarly, next one is a D flip-flop. D flip-flop means one common input of RS flip-flop. Up to here, we discussed two inputs individually, R and S separately inputs, but in the D flip-flop condition, R and S connecting togetherly. That is a commonly. Maybe positive going triggering, negative going triggering, whatever may be, but the two input connected commonly. That is called as a D flip-flop. That can also useful in the 5 markers, very rare case. Once again, you can go through it yourself. I'm not explaining that thing in page number 229. Same similar story only. He given local word only. Just you can go through it. The flip-flop thing. Next one, most important, second one, JK flip-flop. Okay. Either RS flip-flop or JK flip-flop. Out of these two, you can expect one question damn surely in the exam. Right? Or reset to yes set. Okay. Right. Next one, JK flip-flop. Yeah. JK flip-flop. Again here, first circuit diagram. Yes, so or these both are inputs, output Q and Q bar. This input connecting to AND gate output connections. This AND gate inputs, one is J, other one is K. Okay. One input connection connected to other output. Goes on like this. Again, this input terminal connected to another output. This is overlapping the connection line finance. Okay. And a common clock, CLK clock. AND gate, this is thing on. Right. Again, simplest way, examination point of view, first go through this diagram, then you can write explanation about one points. JK flip-flops again having two input terminals, two output terminals. Okay. JK flip-flop having two input, two output terminal. First point. Next point, the JK flip-flop is one such device having with two NAND gates. Having with two NAND gates. These two NAND gates outputs connected to set and reset terminals. Okay. It is implementation from RS flip-flop. Understanding? మీరు బ్యాడ్ చేయకుండా సింపుల్ గా డయాగ్రామ్ చూసి ఎక్స్ప్లెయిన్ చేసేట్లు ప్లాన్ చేయండి. Once again, first point wise you can explain, it will be easy on. JK flip-flop, it can consist two input terminal, two output terminals. One is input is JK, output is a Q dash or Q bar. And JK flip-flops is a device having two inputs with two NAND gates. The two NAND gates outputs connected to RS input, RS terminals. Okay. This JK flip-flop implementation from RS flip-flop only, as shown in the figure. Right. Next one. The output Q. The output Q is connected to K input. Whereas one NAND gate, a lower AND gate input. And Q bar output connected to upper AND gate input. Plus J terminal input. Q output is connected to lower AND gate input. Q bar or Q dash output connected to upper AND gate input. Okay. Up to here is easy one. This cross coupling output input changes RS flip-flop into JK flip-flop. In the previous condition, RS flip-flop, here no cross coupling. అంటే దాని అవుట్పుట్ దీనికి దీని ఇన్పుట్ దాని అవుట్కి అట్లా క్రాస్ కప్లింగ్ లేకుండా RS flip-flop. In JK flip-flop it is a cross coupling. సో ఇక్కడే RS నుంచి JK కి చేంజ్ అవుతుంది ఇంప్లిమెంటేషన్. దట్ థింగ్ అంటే ఒక అవుట్పుట్ ఇంకో దానికి ఇన్పుట్ మళ్ళీ ఇంటర్ కప్లింగ్. That point also you can remember it. Now the input data J is connected to Q bar, K is connected to Q kada. Okay na? Right. Now we can say here the S input latch, it can be get. This is a latch input. It can, one thing is a J, other one is a here Q bar. So you'll be get here J Q bar. The latch of S input J Q bar. Similarly, the latch of R input here, one thing is a K and other one is a Q now. KQ. Okay. In this condition, in this logic followed by the clocked JK flip-flop truth table, we will discuss below. Up to here own ga rayagaltara. JK flip-flop explanation points. Right. Then next we can give the truth table. First thing is a clock. One input is a J, other input is a K, output Q and like Q dash. Last value, profit value is saying Q last value, Q profit. Q last value and Q profit value and a Q bar. In all the cases, we are going to discussing positive going triggering. In that 4 entries, positive going triggering conditions. Here possibilities 0, 0, 0, 1, 1, 0, 1, 1. Input conditions condition. When the first one 0, 0 input you are giving, then no changes in the previous data, that will be get 0, 0 in the previous data. That is no changes conditions. In that condition too, you'll go or else 1, 1. This is nothing but is a no change, NC. Then it can goes to changes when he is going to changing. That 0, 0 bit changes to first bit as it is 1 only, second bit goes to 1 changes to 0 on each. This goes to as a reset. Again, when it is giving 1, 0 condition, previous data is a 0, 0, 1, 1, 0, 0. The next condition 1, 0. Then it can changes to reverse 0, 1. It can changes to 1, 1. Then 1 means it will get a set on. Next again, this data same as this previous data 0, 1. It can goes to changes 1, 0. That will be continuously it get a toggling, nothing but blinking, nothing but prohibited. Toggle, blinking or prohibited. It won't get sufficient data. It can blinking only. Such kind of things. These steps again we have to explain the stepwise 4 steps. When J value, K value 0 conditions, AND gates are disabled, the clock pulse is no affected, then no change in the flip-flop. Next, when the J value, K value, J 0, K value 1, then Q value it can goes to high, but reset conditions. This is a clock pulse giving high, then the S value equal to J only. Q bar value 0 and R value KQ, na? R is nothing but KQ. K and Q value you can multiply it. KQ value will get 1 only. Okay, na? After that, JQ bar value will get 0. That explanation parts we can explain the 4 stages. When J value 0, K value 0, with J value 1, so J value 0, K value 1, J value 1, K value 0, and then 1, 1 conditions. Like that, we can go through it, explanation part. He given clearly, na? Okay, na? This is a JK flip-flop. Similarly, next one, JK master slave flip-flop. JK master slave flip-flop. It means feedback to in output value connected to feedback to input. In that one, that is called as a master slave JK flip-flop condition. That is also important. We'll see that diagram. One second. Okay. The next one, master slave JK flip-flop. One second. Master slave JK flip flop. Master slave JK flip flop. Okay. It is constructed by RS flip flop in the cascade kit. Means nothing but output connected to input, like coupling type. It is constructing by cascading two RS flip flops with feedback from output to input. The first output, second key feedback, second output, first key input. Like that way, we'll discuss the thing is here. Second one, it is a second stage is a slave. First stage, first RS flip flop is a master. Second RS flip flop is a slave type. We'll go through it first circuit diagram with NAND gates. One, then next another one, NAND gate, and here one NAND gate, NAND gate. Okay. Here inputs. One thing is a clock. One input is a J. Other input is a K. Again coupling. Okay. Na? Again, it can give the coupling. This input connected to second, and which is connected to output. Na? This is output. This output connected to this input, and this one input connected to second output, like coupling type. This is a one stage. This output connected to second stage. Again, you can take one more set. NAND gate, NAND gate. Same thing connection, which is connected here. Then finally you can take here output is a Q, other one is a Q dash or Q bar. You can try to finish here. Circuit diagram. This for two inputs, one output clear. Here only one input is there. Then you can give one more time clock here. You can give these both are same clock one. Then you can give the clock connection to yes starting stage. Okay. Up to here one set. This is the second stage. This is slave. This is called as the first one is a master. First block is master, second block is a slave. Okay, na? And next to here, first NAND gate input connected to Q bar output. I'm taking here to connection overlapping. Then goes on first. Q bar output connected to upper NAND gate input. Q connection connected to lower NAND gate input.
అండర్స్టాండ్? ఒక లాజిక్ ఆలోచించి పని చేస్తే అయిపోతుంది. అన్ని సర్క్యూట్ డయాగ్రామ్స్ ఈచ్ అండ్ ఎవ్రీ ఆన్సర్స్ యూ కెన్ రిమెంబర్ లాజికల్లీ one things. Once you have to do the practice, then only be easy. Otherwise it will get a complicated type only. This is a 1 second, this is a yes, this is a R. 1 second, observe circuit diagram. Yes, sorry for the delay. Yeah, okay now? You can observe it. This is a circuit diagram about the JK master slave flip-flop or master slave JK flip-flop. First stage is a master, second stage is a slave. You can explain about the circuit diagram. See, this is a clock, input JK. First NAND gate input connected to Q bar output. Also you can say Q bar output is connected to upper NAND gate. Q output connected to lower NAND gate input terminals. Here, pulse triggering always giving positive clock. Positive clock. Pulse are applying in master and slave circuit. Okay, master and slave. When the clock is high, both in the master and slave flip-flops, it goes to positive going triggering. Input value, when you are giving positive, in that condition the input of RS flip-flop or SR flip-flop value will be get low. Flip-flop cannot change the state. Means it can initially starting condition output values no changes, that is a previous data only it can reflected. When the clock pulse changes to 0, the masters, when the clock pulse positive to negative, when the clock pulse 0 instead of 1 you can give the 0. When the clock pulse giving 0 in the master latch, it can be goes to disabled and the clock slave becomes high. And simple చెప్పాలంటే మాస్టర్ ది హై ఉన్నప్పుడు స్లేవ్ లో 0 ఉంది, మాస్టర్ 0 చేస్తే స్లేవ్ లో హై వస్తుంది, క్లాక్ పల్స్ ట్రిగ్గరింగ్ చేంజెస్ పల్స్. ఓకే, becomes high and it enables the slave flip-flop to flow the data. When it is giving here positive pulse going triggering, in that initial stage is SR flip-flop or slave branch, it can be get disable type on. And ఇది ఎనేబుల్ ఉన్నప్పుడు అది డిజేబుల్, ఇది డిజేబుల్ ఉన్నప్పుడు అది ఎనేబుల్ అవుతుంది. అంటే 0 ఉంటే అది 1, 1 ఉంటే 0. దట్స్ కండిషన్. When the conditions here, if second one slave S is equal to 1 and output of master is equal to 1, output of master is equal to 1. For example, you can take intermediate master QM, it is a QM dash or QM bar. When this S value, this value output value is a QM is equal to 1, then automatically that is connected to input of S na? Then S is equal to 1, QM is equal to 1, then R is equal to QM bar is equal to 0 conditions. I'll say here. I'm writing here. Is it okay? If QM is equal to S is equal to 1, QM is equal to S is equal to 1, and QM bar is equal to R is equal to 0, in that condition, you can observe Q and Q dash value. What will we get, sir, here? Q value will get 1 and Q bar value will get 0. Similarly, you can interchange. QM is equal to S is equal to 0. QM bar is equal to R is equal to 1. Then it will be get output of slave gate, it will get interchanges. Instead of set, we will get a reset conditional. 1 0 is a set condition, 0 1 is a reset conditions. During the positive pulse triggering in the master slave, then does not change in the Q and Q bar value. When the slave clock pulse is affected, then only that output value it can changes. Okay, na? That condition is given in the truth tabular form. We'll take the tabular form. Here rub చేస్తున్నాను. బేసిక్గా ఏం తెలియకపోయినా కానీ సర్క్యూట్ డయాగ్రామ్ డ్రా చేసి సర్క్యూట్ డయాగ్రామ్ నుంచి ఓన్గా కనెక్షన్ రాసినా కూడా మోర్ దెన్ 50% వెయిటేజ్ వస్తుంది. ఓకే, if you get any confused during exam time, just you can remember circuit diagram properly. Based on the circuit diagram, you can explain steps in your own way. అంటే అక్కడ ఏమి ఇస్తున్నాం ఇన్పుట్ అవుట్పుట్స్ అది ఓన్గా మనం మాట్లాడడానికి రాయండి, సరిపోతుంది. ఈజీ టు కమ్యూనికేట్. Nothing but here inputs, nothing but here is a one thing is a preset, other one is a clear. Preset, other one is a clear. Their output will be get flip-flop response, FF response. Your wish, you can go through it combination regularly in the previous condition type 0 0 0 1 1 0 1 1, or else high to low. That is your wish. Okay, I am giving first in my regular way 0 0, then 0 1 1 0 1 1, or else reverse high to low also, anything is fine. When you are giving 0 0, in that condition no used, nothing but not used. In the previous data what is there, that thing only it can reflect it. Okay now, when it goes to 0 and 1, then it will be get set. 1 to 0, it can be get reset. Then when you are giving both input, both values, preset value, clear value 1, then will be get clock operation. In that condition, clock, or else you can explain the reverse order, clocked operation. Okay, no? This is a master slave JK flip-flop things. Is it clear? In the RS flip-flop, with explanation of NAND and NOR gates, and RS flip-flop connected a common input, that is a D flip-flop. In JK flip-flop, it is combination of NAND gates and two stages. One is the master, other one is the slave. In the JK flip-flop a triggering commonly. T flip-flop. Same like in the RS flip-flop, D flip-flop type only. Here in the JK, T flip-flop. Means the input connection connected common. That is called as a T flip-flop. T flip-flop. Okay now. JK inputs, Q bar outputs. Inputs together get common zero. One thing is a clock either 1 or 0 na, then input is either 0 or 1. Am I clear? The input is connected common. That thing you can see in your textbook page number 233. It will be easy on connecting togetherly on. Is it okay? This is a story about the flip-flops. Now you can go through it in your material, page number 234. Examination point of view, previously repeated questions. Question numbers note down. Question numbers. Second one, define a flip-flop, least different type of flip-flops. First page, first 5 types only. Definition of flip-flop already నేను రాయించాను. Type of flip-flops 5 types ఉన్నాయి కదా, 5 types definition రాస్తే చాలు. This is a very important for 5 marks. Sometime they can separately draw the logic symbol of following flip-flops with SR flip-flop, D flip-flop, JK flip-flop. 5 marks లో అడగొచ్చు ఏదైనా 1. Question number 2, 3 important. Next, fourth one. Explain the operation SR flip-flop using NOR latch and NAND latch. This is important. NOR and NAND latch. Next question, draw logic circuit of JK flip-flop using SR flip-flop and explain its operation. That's it. 2, 3, 4, 5. Out of 6, middle 4 questions important examination point of view. 4 launch 1 question damn surely. Okay na? First one, last one, and the important call. Flip-flops lo 1 5 mark question compulsory వస్తుంది. Right? That's it. Next one, registers. Next unit. Unit number 18. Flip-flop simple చెప్పాలంటే డేటా స్టోరేజ్ కోసం వాడాం కదా. టైప్ ఆఫ్ ఫ్లిప్-ఫ్లాప్స్ లో అంటే స్టేబుల్ స్టేట్ లో డాటాని స్టోర్ ఇన్ఫర్మేషన్ ని స్టోర్ చేయడానికి యూజ్ చేస్తే ఇన్ ద బైస్టేబుల్ మల్టీ వైబ్రేటర్ ఇస్ కాల్డ్ యాజ్ ఏ ఫ్లిప్-ఫ్లాప్స్ అన్నాం. నెక్స్ట్ యూ కెన్ గో త్రూ ఇట్ రిజిస్టర్స్. Register simplest way, it can say the group of flip-flops. Registers is a group of flip-flops. ఒక రిజిస్టర్ అనుకోండి, ఒక స్టూడెంట్స్ ఒక సెక్షన్ మొత్తం స్టూడెంట్ డేటా అక్కడ స్టోరేజ్ పెడతాం రిజిస్టర్ వైజ్. ఒక్కొక్క స్టూడెంట్ డేటా స్టోర్ చేయడానికి ఫ్లిప్-ఫ్లాప్ లాగా ఆ క్లాస్ సెక్షన్ మొత్తానికి టుగెదర్ గా పెట్టేదేమో రిజిస్టర్ పెడతాం. సేమ్ లైక్ దట్ హియర్. సింప్లెస్ట్ వే యూ కెన్ సే registers is a group of flip-flops with 2 basic functions capable of storage of data, and it can shifting one place to another place. In that purpose, sequentially, logically moving purpose or shifting purpose will use the registers. Am I clear? Maybe synchronously, asynchronously, the data it can shifting in the registers. Most of the cases will use synchronous with the help of clock. The data it can shifting left to right, or right to left, or top to bottom, or as bottom to top condition. In that condition, we'll use registers. That is the 18th unit. Okay. Here, the data it can shifting in different combinations. In that one is shift registers. Classification here. Shift registers classified into 4 types. Data is shifting na shift register. 4 types. One thing is serial in, serial out shift register. Parallel in, serial out, or serial in, parallel out, parallel in, parallel out. All the cases shift registers. First one, serial in, serial out. Serial in, you can take any order. Serial in, parallel out. Third one, parallel in, serial out. Parallel in, parallel out. Parallel in, parallel out. Simple, sir. Logical. Basic thing. Serial in, the data it can shifting serially, entering, serially leaving. One bitwise shifting. For example, here 4-bit data. First ఇక 0 ఎంటర్ అయింది అనుకోండి. నెక్స్ట్ ఏం చేస్తాం, 1 ఎగ్జిక్యూట్ చేస్తే ఈ 0 ఇటు షిఫ్ట్ అవుతుంది, 1 ఇక్కడ వస్తుంది. నెక్స్ట్ ఇంకో డాటా షిఫ్ట్ చేసాం అనుకో, అప్పుడు ఈ 0 ఇటు షిఫ్ట్ అవుతుంది, ఈ 1 ఇటు షిఫ్ట్ అవుతుంది, ఇక్కడ కొత్త డేటా 0 వస్తుంది. ఏది ఎంటర్ చేస్తుంది. నెక్స్ట్ మళ్ళీ 1 ఎంటర్ చేసాం అనుకో, అప్పుడు ఈ 0 ఇటు షిఫ్ట్ అవుతుంది, ఈ 0 షిఫ్టింగ్, ఈ 1 ఇటు షిఫ్టింగ్, ఈ 0 ఇటు షిఫ్టింగ్, ఇక్కడ కొత్తగా ఇచ్చిన డేటా ఇక్కడ వస్తుంది. సీరియల్ ఇన్, సీరియల్ అవుట్. నెక్స్ట్ ఏదైనా ఎంటర్ చేస్తే అప్పుడు ఈ ఫస్ట్ 0 అవుట్ అవుతుంది. ఫస్ట్ ఇన్, ఫస్ట్ అవుట్, పిఫో. ఓకేనా, పిఫో సిస్టర్ లాగా. సీరియల్ ఇన్, సీరియల్ ఇన్ ఆల్ ద కేసెస్ పిఫో ఓన్లీ. ఫస్ట్ ఇన్, ఫస్ట్ అవుట్. The serial in, serial out conditions. Serial in, parallel out. అంటే డేటా ఇన్పుట్ ఎంటరింగ్ అయినా సీరియల్ గా ఇన్పుట్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ 4-bit డేటా తీసుకుంటే 4-bit డేటా సీరియల్ గా ఎంటర్ అయిన తర్వాత ఫస్ట్ 0 ఇదే డేటా తీసుకుంటా, 0 1 0 1 ఇచ్చాను అనుకో, ఆ డేటా 4 bits వరకు ఇలాగే ఎంటర్ అయిన తర్వాత సీరియల్ గా 1 0 1 0 ఫర్ ఎగ్జాంపుల్, వీఆర్ ఎంటరింగ్ సీరియల్లీ. After that, parallelly entering, exiting and going out. Together వెళ్ళిపోతున్నా. సీరియల్ గా ఇన్పుట్ ఇచ్చాం, ఒకేసారి ప్యారల్ వెళ్ళిపోతుంది. అంటే ఇక్కడ అవుట్పుట్ మాక్సిమం వెళ్ళిపోతుంది డేటా అనేసి. అండర్స్టాండింగ్? సీరియల్ ఇన్, ప్యారల్. సీరియల్ ఇచ్చే ముందు ఏంటంటే 1 bit ఇవ్వాల్సి వస్తుంది, అవుట్పుట్ ఏమో ఒకేసారి వెళ్ళిపోతుంది. ఈ 4 bits ఒకేసారి ఎగ్జిక్యూట్ అవుతాయి. సీరియల్ ఇన్, ప్యారలల్. నెక్స్ట్ parallel in, serial out. Parallel in, serial out means input it can take parallelly, output will go slowly 1 bit. ఇది రివర్స్ గా ఈ డేటా ఇన్పుట్ వచ్చిన తర్వాత ఏమొస్తుంది, అప్పుడు 1 bit సీరియల్ గా అవుట్ అవుతుంది. అలా కాకుండా లాస్ట్ కండిషన్ parallel in, parallel out. For example, you can take rough work this only. 4 bits entering serially, parallel గా, అంటే సారీ మై బ్యాడ్, 4 bits entering parallel 1 0 1 0 together గా. At the same time 4 bit leaving from the register parallel. ఆ సెంటెన్స్ లో ఉంది అక్కడ. serial in, serial out, parallel in, parallel out. This one they can stay stage 1, stage A, stage B, stage C, stage D atla లేదా stage 1, 2, 3, 4. ఈ మెయిన్ కీ పాయింట్ బేస్ చేసుకుని మీరు ఓవరాల్ గా ఎక్స్ప్లెయిన్ చేయొచ్చు. ఇట్ కెన్ క్లియర్ అదే అన్నాడు SISO సీరియల్ ఇన్ సీరియల్ అవుట్ షిఫ్ట్ యూజింగ్ డి ఫ్లిప్ ఫ్లాప్. డి ఫ్లిప్ ఫ్లాప్ లో కామన్ గా కంపల్సరీ ఇన్పుట్ ఒకటే ఇవ్వాల్సిందే. అక్కడ 1-0-1-0 ఇస్తున్నప్పుడు 1-1 బిట్ కంటిన్యూగా ఇవ్వాల్సిందే. రైట్, దట్ ఈస్ ఏ serial in, serial out conditions. You can go through it. This is a easy explanation part in your material page number 236, 237. అన్నిట్లో అంతే, ఓన్లీ థియరీ ఉంది, స్టోరీ చదివేస్తే సరిపోతుంది. Serial in, serial out shift register using D flip flops. I took here 4 bits. He took there 3 bits. 3-bit SISO shift register is taken in the flip flops. అంటే 3 ఫ్లిప్ ఫ్లాప్స్ లో రిజిస్టర్స్ అంటేనే సింపుల్ చెప్పాలంటే గ్రూప్ ఆఫ్ ఫ్లిప్ ఫ్లాప్స్ కదా. అక్కడ 3D ఫ్లిప్ ఫ్లాప్స్ తీసుకున్నాడు, DRS ఫ్లిప్ ఫ్లాప్ లా. సో ఇన్ దట్ వన్ థింగ్ 3-bit shift register uses 3 flip flops with a common clock. The data D0, D1, D2 like that. First flip flop, the output first flip flop given to the input of D1 and D0 output value you can give to D1 input. Next D1 output value giving to D2 output. So D2 input. Okay, దాని output ఇంకో దాని input continuation. The input data D0 of flip flop is transmitted to output of Q0. It is transmitted to second flip flop giving clock pulse and clock pin. After second clock pulse, the data transmitted second flip flop. ఇక్కడ ఏం లేదు చెప్తున్నానంటే వాడు 3 ఫ్లిప్ ఫ్లాప్స్ తీసుకున్నాడు. ఓకేనా, D0, D1, D2. Then next here clock, then clock, then clock. CLK clock, which is Q0, then next Q1 will be get Q2. Then here Q0 dash, Q0 dash, Q1 dash, Q2 dash. Am I clear? Q2 dash values, right? Which is a input things, which is a input things, right? This is a data in, this is a data in output. Finally we'll get here data out, data in, data out, connection connected like this. Okay, these connections connected when the data in, data out. One second. హలో నమ్మదే, నేను నమస్తే, నేను క్లాస్లో ఉన్నానప్పుడు నేను చేస్తున్నా 1 అవర్లో నీకు చేసుకో. దిస్ డేటా ఇన్, డేటా అవుట్. Data in, that is a data out. 3 stages. This is stage A, this is stage B, this is stage C. Stage A, B, C. Whatever input, this is connected to giving to Q0, means first flip flop output. That Q0 connected to second flip flop input. This D1 second flip flop output is a Q1. That Q1 is connected to second flip flop input. Continuously can goes on sequentially 1 bit out. Serial in, serial out. Serial in, serial out. Okay, no? Serial in, serial out. Is it clear? This thing you can read, it will be easy only. Serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. It can be easy only, storage part. You can read yourself, all of you. దీంట్లో అంత మేజర్గా ఇంపార్టెంట్ క్వశ్చన్స్ ఏం కనపడలేవు. ఐఎమ్ ఫీలింగ్ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ, వాట్ ఈస్ ద షిఫ్ట్ రిజిస్టర్, classification of basic shift registers, these two questions important second bit. I hope you'll understood. You'll read yourself these 4 type of shift registers. You can follow from the textbook. It can easy to understand. I'll stop here only class up to 18th unit. In the next class, I'll try to finish 19th and 20 unit. Then it can be finished this block. Then next we can go to 4th block, then come back to 2nd and 1st block later after finishing up these blocks. Is it okay, dear students? We have 2-3 weeks now next coming. I think we have 3 more weeks. Okay. In that 3 more weeks, I'll try to finish myself the syllabus. But before that, you have to plan yourself. Why? Because you all are also masters only, not a college students. I'm feeling you are also one stage masters only. So that's why my suggestion is before the class, you can go through it yourself preparation. That will be better. My target, I'll try to finish definitely in coming couple of weeks, remaining syllabus. Okay, don't worry about the syllabus. I'll try to finish in this speed only. If you need any extra after finishing up this college schedule, I can plan in the evening hours extra classes. Okay, that is based on your requirement. I will teach in the online mode only. Okay, right. Is it clear? I'm stopping here only today. Then you can go through today, revision yourself. Unit numbers 15, 16, 17, 18. Okay, these 4-5 units you can read now only, means today only. Then will be easy. Otherwise, it will take 1 or 2 days time. Automatically, this terminology changes when you are observing everything looking logically type only. That's why immediately you can read as soon as possible. Early only you can plan your schedule, and you can underline main points in the textbook with pencil or pen. That learn sentences, you can go through it your own language. No need to explain that as usual textbook language. Just you can connected sentence way, you can try to explain the own way. Definitely you will get marks. And here the thing is, important thing is, you have to practice should and must circuit diagrams. Why? Because in the electronics paper, all the question maximally circuit diagram based questions only. All the questions circuit diagram based questions only. Okay na? So once you can practice circuit diagrams, and you can try to attempt all the question answers in the exam paper. That is the one benefit. Okay, definitely you will get better score comparing with other subject. I told yesterday class also. Why? Because I'm observing the previous 5-6 years. Hardly I'm teaching 8 years onwards, 2014, 15 onwards. 2014, 15 onwards, I'm teaching same paper. When I compare any situations, even the toughest situations, definitely the most of the students getting highest score in this paper only. They can feel easy after learning all the subjects. They can feel easy. 50% this is the already learn in the intermediate and degree standard. Okay na? That's why it will be easy only in old terminology comparing with the other subjects. Okay, anyhow, don't wasting of your time and my time. You can go through it well preparation from your side. If you get any time, any doubts, you can WhatsApp to my WhatsApp number. I'll give a reply based on my convent. Otherwise, I'll call back you and explain that answers also before exam. Anytime you can read and you can go through it, that topics. If any doubts, you can share that questions to my WhatsApp number. Okay, right? Bye. Thank you. Thank you, Vasavi. Now you can say if you any doubts, you can chat here. Otherwise, you can leave. Okay, thank you for everyone. Yeah. Is it okay? Done. I think no questions are here. All are saying thank you only. Okay. Thank you from my side also. Okay, okay. Outside you won't available any kind of material. This is your material only, textbook, guide, everything also. Okay na? Bye.